In today's class, we are going to discuss about body projected up from top of tower. From top of tower. So I am taking one tower here, and a body is vertically projected upward. Vertically projected upward from this tower. So it reaches to some maximum height and comes to rest and falls down to the ground. Here the velocity of projection is which we are projecting is u, and it reaches to the ground, and the velocity of striking here is, let us strike it as vs, and the height here, let us take from here to here how much height means small h. Small h is height of the tower, u is velocity of projection, vs is velocity of striking, and small h is height of the tower. And now t is time taken for the journey. Time taken for the journey. For the journey means this is the projection point. It reaches the maximum height. Maximum height velocity 0. Again it comes down and reaches to the ground. Reaches to the ground. The total time taken for the journey. The total time taken for the journey is small t. Here, let us observe. Let us take the distance from here to here as x. Let us assume from here to here distance is x. Here this is a maximum height point, where that maximum height point here velocity at this point is equal to 0. So velocity at maximum height is 0. We know that velocity at maximum height 0, so that the body comes down. Now in this situation, first what you have discussed means what is displacement. The main topic is about displacement here. So displacement, what we have to take, that is the main topic to be noted for the body projected up from tower. So displacement means, it is, remember, this is a vector quantity. It is a vector quantity. It has direction. It has direction. So now we start our journey from here. We went to here displacement of x, and again coming down x, again coming down h. So as displacement is vector quantity, in one initial direction which you are moving, that is positive, means later direction you have to take negative, because displacement is vector. Initially we are traveling from here to here is x, again coming down x, again h. So first x going upward direction, always initial direction you have to take it as positive. So s is equal to, I have to take here x. Afterwards, after traveling to here x, it is coming down here. Coming down here means now direction is opposite. Here upward direction, downward direction. We told it is displacement. We have to give the sign convention here. Coming down means I have to write here minus x. After that you observe carefully here. So I have written here is minus x. Now I am coming down again to here, a height of h from here to here. So first x up positive, x negative, downward, because downward. Again we are going down only, the down distance only we are traveling, that is h. So again down means, again you have to take here minus h. So clearly you can observe here, x and minus x are cancelled. So the displacement in this situation, you have to take it as minus h. Displacement is always shortest path covered between initial point and final point. So direction is minus h, because body projected up. So displacement is always taken shortest path from initial point to final point, from here to here. It is taken as minus h. So here s is equal to, what we noticed is minus h. Okay, well done. Now what about the remaining values? What is u means? We can write it as u. What is acceleration? The body projected up. We told the body projected up. So body projected up means acceleration is minus g. Minus g. Don't think that we are going up and again coming now down, sir. So we are taking this part, for this part it is minus g, we are coming down part plus g. No need of that information, because we are not treating this as an individual. You are not treating only for up and only for down. You are not taking. We are taking this as a single motion. This is one single motion. The two displacement only from here to here. We treat it as a single motion. So simply acceleration we can write as minus g. Don't get tensed about what will happen while coming down is plus g, no sir, minus g. Why? The reason we are taking it as a single motion. Simply, what is the thing when initially it is there? Initially projected up, so a equal to minus g. And time taken here, what is the time taken means t is equal to t. So substituting this data in our beautiful formula, S is equal to ut plus of at square. From equation of motion, S equal to ut plus of at square we have. Let us substitute in this one. What will happen? Let us check it out. Here S is equal to, I told, minus h. U is for t and a value is minus. So minus h is equal to ut minus of gt square. So from here I can write h is equal to minus ut plus of gt square. Nothing I did here. The minus I send other side. So minus of minus will become plus here. So here we'll get plus, here we'll get minus if you send minus other side. So this h is equal to minus ut plus of gt square, and this h is called tower height. Tower height. H is called tower height. So the tower height formula what we got is h equal to minus ut plus of gt square. Now our target is to calculate what is the velocity with which it reaches the bottom. Velocity with which it reaches the bottom. So projected velocity is u, reaching velocity at bottom of the ground, striking the ground is v. And no doubt this is h, and this is a equal to minus g. Already we observed all these things. Now we have written also this one, u equal to u, a equal to minus g, s is equal to, we have given it as minus h. I think you remember s is equal to minus h, how we got this information here. So here s is equal to minus h. So as that is clear, now we are writing here also s is equal to minus h, and velocity of striking v is equal to v. So what is our formula means? V square minus u square equal to 2as. Let us substitute here. V value is here v only. U also u only. Here a value is minus g. S value is minus h. From here I can write v square minus u square is equal to 2gh minus of minus it became plus. So that what is the v value? Velocity of striking value means u square plus 2gh. U square plus 2gh. So velocity of striking the ground. What is v? Velocity of body striking the ground. Velocity of body striking the ground. Striking the ground. This is the velocity what we got. I hope you are clear with this one. How we got velocity of striking also. So this is the discussion what we made. Let us observe some important points here. So what we noticed here is whenever a body is projected from certain height, that is from top of tower and reaches the ground, this distance is h and projection velocity is u. Here the time taken is t and reaching velocity v. So we got the formula as h is equal to minus ut plus of gt square, and velocity of striking we have written it as v is equal to square root of u square plus 2gh. So these two things we noticed. Now let us have some discussion on these two things better. So I'm taking one application like this here. If a body is thrown downward from a tower, so now from the top of the tower of height h, from the top of the tower height h, the body is thrown down. The body is thrown down. So here u is not equal to 0, vertically projected down. U is not equal to 0. It reaches the ground with a velocity v1. So here again one more body is projected up and reaches the ground. Here also it is projected with the same velocity u, and it reaches the ground with velocity v2. So it is vertically projected downward. The height is same in the both the cases. Height is same. So I can write from here this information. This is actually vertically projected down. Vertically projected down situation. Vertically projected down. So now if you observe in vertically projected down situation with a velocity u and vertically projected up, vertically projected up from tower, vertically projected up. So I am taking here vertically projected up from top of tower, from top of tower. In the both the situations, if you observe, in the both the situations you observe, here what is the velocity means here also what we have here is v1 is equal to, we have square root of u square plus 2gh. Here also what we observe here means again v2 also is equal to, v2 also is equal to square root of u square plus 2gh. So in the both the situations, that is the when velocity projected down with the velocity u, and velocity is the u when projected up. Velocity with which you are projecting is up is u and reaching to the ground. Here velocity v2, here velocity v1. Both are same. Both are same. So from these two conclusions, what I can give that beta? v1 is equal to v2. Both the velocities are same. This is my conclusion. So I hope you understood that if a body projected down from a height h, if a body projected down from a height h, or if a body is projected up from certain height h, so with the same velocities, both the situation initial velocities are same, then final velocities are also same. Final velocities are also same. Because here displacement is same. Here displacement is same. Initial velocity is same. So we got the final velocities are also same. Final velocities are also same. I hope you are clear with this one. Now